Investigating Resistive Forces by Rachel Hamrick, Kelsey Koss, and Farouk Iqbula. Our research question is, what are the relationships between the velocity of a metal ball bearing falling through the resistive forces of water, isopropyl alcohol, and corn syrup? We hypothesized that because of force is proportional to velocity, we believe that the higher the velocity, the lower the viscosity. And in order, the viscosities go corn syrup, water, then isopropyl alcohol. One of the possible errors that we thought of was not being able to reach terminal velocity by the time the metal ball bearing reached the bottom of the graduated cylinder. The way that we designed our experiment was that we would have one graduated cylinder filled with one fluid, water, then we'd have a second one and a third one filled with alcohol and corn syrup, and we would take a small metal ball bearing, and drop it from the top and record it. Then take the video analysis and use Tracker in order to find the velocities and accelerations for the acceleration time graph. We believe that the ball traveling through the corn syrup would have the smallest velocity and the highest viscosity, while the ball traveling through the alcohol would have the highest velocity and lowest viscosity. The corn syrup would be the only fluid that would actually be able to reach terminal velocity out of all three trials as well.
For our experiment, we used a diagram of the scenario, a force diagram, and a system schema to describe what was happening. Our force diagram shows that there is an applied force on the ball by the fluid in the upward direction and a force of gravity on the ball by the earth. Upon analysis, the data for our water trial shows an increase in velocity and acceleration over time. The acceleration versus velocity has a negative slope. The viscosity coefficient for water is shown to be 0.14. Our data for alcohol shows an increase in velocity and acceleration over time as well. This is a slightly bigger increase than we saw for water. The slope of the acceleration versus velocity graph is also negative. Our mu coefficient is 0.236 for alcohol. Finally, our data for corn syrup shows a very small increase in velocity and acceleration over time, and a much larger decrease of the slope of acceleration versus velocity. Our viscosity coefficient is 0.397, and we found a terminal velocity for corn syrup to be negative 32.2.
In our experiment, we used the concept of forces to determine acceleration and therefore a terminal velocity of a ball sinking through three liquids of varying viscosities. Acceleration can be determined by the mass of an object and the net force acting on it by Newton's second law. To get terminal velocity, we would have needed to take the net forces acting on the object, which is the viscous force, minus the gravitational force, and set it equal to mass times acceleration. Then you would rearrange the equation to equal acceleration. This equation looks like y equals mx plus b, which is the basic equation for a straight line. Using this, we can find mu by measuring the slope of the acceleration versus velocity graphs and set that equal to the viscosity over mass portion of the equation to solve for mu, as we know all the other values. We can then find terminal velocity using this equation with the solved mu, which would then be solved when acceleration equals 0. We didn't expect to get good results from water and alcohol, as the tube we dropped the ball in wasn't long enough to observe terminal velocity, but we should have been able to see the ball reach terminal velocity in corn syrup since it was dropped before it hit the corn syrup. It would have gone faster than corn syrup terminal velocity, so it would have slowed down to a constant velocity that we would have been able to observe since the ball fell so slowly in the corn syrup. The large viscosity would have mitigated the problem of not having a long enough tube to observe the terminal velocity. Our expected results should have shown corn syrup being the most viscous, and alcohol would have the fastest terminal velocity due to its low viscosity, which means less force acting against the ball as it falls. Instead, we found alcohol to be more viscous than water. but this could be attributed to the very little data we collected and not having a long enough tube to drop the ball in, so we could not collect enough data to accurately calculate viscosity. The most surprising result was that corn syrup had the fastest terminal velocity despite having the largest viscosity. Out of the 3 liquids, we would have expected to get accurate results from the corn syrup trial. This could be due to inaccuracies in data collection, as the collected acceleration versus velocity graph did not match the expected graph using the equation. The physics should follow that the most viscous liquid should have the slowest terminal velocity.